All right. So Pepsi claims that cans are filled to 12 ounces. Suppose a sample of 40 cans reveals a mean of 11.89. And we have a known population standard deviation of 0.65 ounces. Okay. And we're doing alpha equals 10%. To determine if Pepsi is filling cans with less than. So less than 12 ounces would be that would be my alternative hypothesis. So my null would be greater than or equal to. And in this case, we are using the traditional method. So if we want to figure out traditional method means find a rejection region. Are we using Z or T here, guys?
T.
Why?
T. This is a sample.
Hold on. What we have is the population standard deviation.
No.
So that would tell us we are using Z. So Z means mean of 0, standard deviation of 1. Okay? And when we do our shading here to find our rejection region, are we doing left, right, or both?
Left.
How do I make that determination? Not the alpha. The alpha tells me how much I'm shading. Okay? The alternative hypothesis tells us where we're shading. Okay? What's our alternative hypothesis? Less than. So I'm shading left. And now how much am I shading? 0.1. So we are going to reject if Z is less than whatever this area or whatever this Z-score ends up being. Grim, what'd you get?
1.28.
1.28 sounds about right.
Where do we get that again?
Inverse norm.
Reject if it's less.
So we're rejecting if we get a Z-score for our sample that is less than negative 1.28. Everybody good? Okay, so what do we need to do next? Calculate the Z to decide, is my Z less than negative 0.28, negative 1.28? Now, how do I get the Z-score? There's a formula, which is on your formula sheet, or plug it in the calculator. I'm going to show you how to plug it in the calculator. Which one should I pick here?
Z interval.
I don't think so. A Z interval would give us a confidence interval.
Z times Z
Is this a proportion?
No.
No. So we're just going to pick the first one, Z-test. Okay? All right. What should I put for the mean of my null hypothesis? 12. My standard deviation, I'm going to put 0.65. I'm going to highlight summary stats at the top, sorry. My X bar, I'm going to put the X bar. My sample size was 40. And then just leave this part up there for a while, see how you guys are doing with it. It asks, so notice, as I decoded the question and wrote all this stuff down, this is the information that I end up kind of putting into my calculator. A lot of it anyway.
Z-score is 1.07.
Negative 1.07.
Oh.
Whoa. I got a very different one. Hold on. Mine's wrong. I know mine's wrong. Isn't it?
It's all the same. There it is. Top,
It's from one above.
top right. -1.07.
Okay.
It's right there.
Oh, I think I hadn't, like, yeah. So it was doing it from whatever data was in my calculator, which...
Yeah, just look above that one. It says thing. Is that what you got?
Yeah.
Yeah.
Oh, yeah, okay. That makes sense. Okay.
Which is greater than the rejection region, so it's okay.
So are we rejecting or not rejecting?
We failed.
So we might say something like negative 1.07 is not less than negative 1.28. Right? And that's our reasoning. That's our why. So from here we'll say we cannot reject H0. And then we do not have enough evidence to reject the claim that
We like say the same stuff, but like most things just like change out the.
yeah, even that, like, I might say to say Pepsi is underfilling their bottles, their cans.
Synchronized snip.
Okay, so you guys, let's look at this one next. This time, notice that I'm asking you to use the p-value method instead. And this is a much better, this is a good guide for what your test will look like, where you'll have a question and I tell you which method to use. And the majority of them are running, there's 3 of the 8 questions are running tests. Okay? All right, and the instructor claims that the mean grade on test number 1 of their course was greater than 80. Suppose a sample of 36 reveals a mean of 81.065. What are my hypotheses? The null would be mu is less than or equal to 80. The alternative would be mu is greater than 80. Okay. Use a population standard deviation of 2.457. So what does that tell us? Z. Okay. And alpha equals 0.02. Okay. So let's go ahead and we actually wouldn't even need to do this, right? Because we don't need a rejection region in this case, do we? Because I'm asking you to use the p-value method. Okay. So next what we have to do is find the z statistic and the p-value. Okay. We're going to do that the exact same way we've already found the z statistic. Everybody with me? Okay, so I'm going to go to stat, I'm going to go to test. Which one should I pick? Z-test. This time this time we're doing it from summary stats still. Okay, I'm going to clear out that null hypothesis, and this time I'm going to put in 80. My standard deviation, I'm going to put 2.457. My X bar, I'm going to put 81.065. My sample size, 36. My alternative hypothesis is greater than. Everybody good?
Yeah. I got a very small.
Oh. Is that,
But that's how you find the p-value.
so that's the P right there. We can use that.
What does the P correspond to?
The p is the probability you could get that sample if the null hypothesis is true.
Okay.
If the equal to part of the null hypothesis is true. So it's like, oh, the sample is what actually occurred. Could that have occurred if that null hypothesis is true? If that answer is probably not, if it's low,
Yeah.
that gives us pretty good evidence that that null hypothesis is not true. So we can reject it. All right, so the Z statistic I am seeing here is 2.60, and the p-value is 0.0047, which is very low, which is, so how do I decide if my p-value is small enough? Well, that answer is alpha. So this time my p-value is less than 0.02. It's always less than, okay?
And if it's greater than what?
If it's greater than, this example up here, the p-value would have been greater than alpha. So less than means we can reject the null. And our reasoning is this. So like the why can we, that's like it's going to... Therefore, we can conclude the instructor's test grades or the average of them is probably an important idea. We're higher than 80. Is this clearing up kind of like how we make those decisions?
Yeah. This is kind of just like putting it all together.
Yes, 100%.
This just makes a lot more sense.
And that was the intent of yesterday's stuff, was also to put it all together when it's a proportion. All right, we ready for the back side of this, and then we're done?
When does this mean we have the rest of today, Thursday and Friday for both labs?
That this means that you will have essentially the rest of today, Thursday, Friday, Monday to finish up whatever you need to do in order to take the test on Tuesday. So it essentially gives you a week to get through the assignment / study for the test, which I feel like is a reasonable amount of time. And I think you guys were going to finish the lab early and then not have stuff to do. So I think this makes a little bit more sense. All right. So let's go ahead and look at this one. One college magazine reports that the average student works 32 hours a week over winter break. Use a 10% level of significance to determine if the average is different than 32 hours per week. All right, so guys, let's start with my hypotheses. What would they be?
So 32, so M equals 32 on the HA.
On the HO. Whatever has the equal to is always your null hypothesis, no matter what. And then my alternative is going to be not equal to.
The determinant between mu and, what is that, S?
In this case, well, we don't have a standard deviation, do we?
No, I'm just saying like,
So we've got alpha equals 0.10, and that's all we have. And then we have the raw data, yeah? So, do we have the population standard deviation? No, so this would be a, so this tells me t-test. Great. All right, so then, what do you think we need to do next?
Put in the numbers.
Put the numbers.
when do we use, isn't there another, yeah, when do we use mu versus p? Oh, it's just if it's the p.
If it's, well, no. It's, how do you know when you're using mu versus p? Depends on what are you measuring. This is measuring an average.
So 32 there. The average is 32.
So I just typed them in my list by hitting stat edit. And then you're going to choose option number 2, t-test, because this is a t-test. And this one we're doing from our summary statistic, or no, from the actual data itself.
Why don't we like write down any of the information?
What information?
The mean.
Because we don't have it yet. What we have is that we have to, like, when we go and run the t-test, so when you highlight data, all it does is fill in L1, and it's going to go in, when it runs this, it'll report out what the mean and what the sample standard deviation and the sample size and everything was. But if you look at what we were given, we weren't given any of that information. We were only given the raw data. Okay? So let's see. This would be 32. We choose not equal to.
Will the test tell us to either use traditional?
The test will tell you to either use traditional or use the p-value method. So I need you guys to be comfortable with both. Though I certainly think the p-value method is easier.
So wait, p-values for proportions?
Nope. Okay, there's a difference between p and a p-value. The p-value is the result of running one of these tests. P is the proportion of a population, like the percentage of the entire population. It's just not the same thing as this p-value.
Oh, so traditional method is like drawing out the.
Traditional method would be we figure out what are the t's that would make us reject the null hypothesis. Since we didn't do that in advance, we're going to use the p-value for this one, and then I'll remind you guys how to do the traditional method for the second one. Okay. All right. So once I hit calculate, I get my t statistic is equal to negative 0.156. I would like you to report that no matter what. My p-value is 0.88. And then we have x bar equals 30.8 and n equals 6. Why is my p-value so high?
Is it because of the sample size?
Sort of. So as we look at this, the whole goal of the test is trying to decide, is the distance from what my sample says and what my null hypothesis say, is that a significant difference? Is there a big difference between 32 and 30.8? Well, not when your sample size is 6. Okay. Now, we could have gotten this exact same sample mean, but my sample size was 100. That would be a pretty big difference, because we would expect if I have a sample of 100, that the means would be closer together. Okay? So we use the p-value instead of just looking at, the mean is off by 1.2. Is 1.2 a lot? It depends on a lot of different factors. Okay? So we have 0.88 is greater than 0.10. So I want you to say how are you making your decision? Which means we fail to reject the null hypothesis. So we don't have enough evidence to conclude the average hours per week over winter break is different from.
So this test is Tuesday only? Or is it?
Correct. Because it's a block day.
Can you write it as not less than?
Yes, that would be fine. That would absolutely be fine.
Can you give us a description of the test?
Yeah, it's got 8 questions that have parts A, B, C. I want to say there's 24 total. It's shorter because it's only over 2 units instead of 3. There will be questions relating sample size to margins of error. There will be questions regarding level of confidence to margins of error. There will be questions where you have to run tests. I think there's one question regarding type 1 and type 2 errors that feels pretty reasonable. Everybody good? All right. So this one we are going to do the rejection region idea traditional method. A company who allows employees to work flex hours claims that the average hours worked is at least 40. In a sample of 20 employees, the mean time worked was 38 hours with a standard deviation of 0.56. Does that say population standard deviation? No, and in fact, it's in the exact same sentence describing the sample, yes? So that is an S equals 0.56.
Exponent's 30. Yeah, okay.
And alpha is 0.025. Okay, you guys, in this case, the claim is working at least 40 hours. So what does at least mean? Mu is greater than or equal to, which means now the claim will be in my null hypothesis. And that's okay.
I'm so confused about that. I wanted to just like bring the right one in the A.
You don't know which one's the right one.
But
That's the whole point of this, is we're trying to decide, is it possible to rule out one of these?
how do you know?
That's what I'm saying, like, how do we know when to put it to?
The equal to,
Well, yeah, but like, how do you know to make it?
because at least means greater than or equal to.
And is that always going to correspond to the null?
The whichever of the hypotheses has the equal to sign is the one that goes in the null.
At least isn't just equal, so that's why you put it in the middle.
Correct.
And then, is the null always going to be the one that's stated in the problem?
The null is always going to be the one that has an equal to in it.
Yeah.
Okay. All right, just a reminder for these T's, because this is a good reminder, okay? Where am I shading here? Left or right?
To the right.
To the left.
You always use the alternative hypothesis to make the call.
With 0 to
0.025.
Degrees.
And this time we're not using Z, we're using T. So instead of labeling the standard deviation as 1, we just label our degrees of freedom, which will be 19. And in our calculators, we're going to do inverse T.
Why are we using T again?
Because we don't know the population standard deviation.
Okay.
19. Oh, yep.
Mine looks a little bit different than yours. All right, now what? We choose t-test because we've got to figure out what t is. This time what we have are the summary statistics. The X bar was 38. Whoa.
My calculator. Everything is the same except for P. My P just says 0.
That's fine. Because notice mine does say 0. It's just the,
To the negative 13.
yeah. And that's like, that is a 0. Because that's like times 10, move that decimal place over 12 places or 13 places or whatever. Everybody good? You guys, so, is that less than negative 2.09?
I think so.
I think so too. I think so by a large margin. So we would reject the null hypothesis. In this case, we are going against the claim. This sample disproves this claim. Whether you know the population standard deviation or not.
Okay.
How is the F19?
It's your sample size minus 1.
Oh, okay.
So the population standard deviation is when we use C.
Uh-huh.
Charlie got
right, let's take a break. I'm gonna go run out the labs for you guys.
This is me notes and right. I didn't know we said just gonna slice for
days. That's all I'd say. You're done. Oh, hey man, how are you? My fellow Brassican.
Yeah. When are you coming back?
June 1st.
Yeah, right.
I am. I need some money, let's be honest, yeah.
Yeah.
The reason I nothing life.
What are you gonna be though?
Have a new animal girlfriend.
What?
You're still gonna have a zoo animal girlfriend.
That's crazy. That's crazy.
Spread it.
Yeah, right. Okay. That's
I'm
crazy.
going to the bathroom. Do you need anything?
There you go. Okay. Yeah. That's what I was gonna say.
Why would you want to make me come? I have an appointment I have to leave for an hour.
I mean, this is kind of.
I was already late.
Beck, you missed out last night. Mario was unbelievable. That was insane. He's actually like way too good at the game too. But he was literally talking like this. He was like, "What are you guys doing?" He said, "Run a picture of this card after 20 minutes," and he framed it. Like he kept taking hits during the game. Oh, insane.
Mario's the new plug.
No, it's not.
Yeah, he is.
What the heck? Are you showing pictures today?
Yeah.
Charlie, what should I make for breakfast?
Some scrambled eggs.
Nah, bro. Omelet. Okay.
Beck, you ready for tomorrow?
The game?
You locked in.
No. I'm actually regretting playing. No. I'm not. Obviously, I'm not going to quit, but regretting starting baseball.
Graham, you like the new race?
The what?
The new race?
Yeah.
Nebraska?
It's good.
Connor Rice is a purple.
You would like the race. You would be. You would.
It's just like more cinnamon. More cinnamon.
So my mom said she's not going back until they change it back. So you know
Wait,
Garrett.
is there
I'm
no
sure,
other
I'm
option?
sure they'll change it back now.
No, they're not going
Since
to.
your mom.
You know
Yeah, since
Garrett,
Beck's family doesn't like it.
Coach Garrett that bad.
Darn.
People hate it.
I don't think that happened.
I
but okay.
don't think that's causing issues.
There's no way Garrett would
I'm
say
not
that.
eating.
I worked,
Oh,
I worked host last Friday and we had like 18,000.
That was the made up Roman story I've ever heard back.
You're just stupid.
How
How was that getting?
Did you hurt these?
What? I don't even know what he said. He was like, I was getting to school today. Fucking late. He said like you're 20 or something. Doesn't that just mean you get like time?
Yes.
Well, that's, wait, do I have a clear? What is here?
I just think you,
You know what?
they're kind of cool.
Where are they?
Did you hear
They're,
about the video from
Yukons.
Friday?
Yeah. No, they're actually sick.
Yeah.
You guys,
Tahoes. Yeah.
they got
They're like,
Can I say that? Oh.
dark blue.
like
They are
so
sick.
what other things?
Was that a yes?
And you're like, whoa, dude, that's a cool car, bro. Nice car.
So stop.
Thank you, Miss Natalie. Just stop.
Yeah, I'll send it to you now, right?
Oh, this is gonna be a good car.
Huh?